All right, standard form of our quadratics, we have ax squared plus bx plus c. We remember a, b, and c are real numbers. No, you're not having deja vu. I had to re-record this. Okay. So, now, we also talked about a cannot equal 0. That will no longer be quadratic if its a is 0. A will also tell us the orientation and shape of the parabola. We've noticed that when A was negative, it opens down. When A is positive, it opens up. All right? There's more to the A value. We'll spend a whole day on it next week. All right, so I'm giving you a faster way to graph these in standard form. If you're in standard form, you have to be in standard form to use this equation. We're going to find the middle of the graph first. That's the symmetry. Remember, our axis of symmetry is a vertical line, so we're going to write the equation like a vertical line. How do you write that? X equals some number, some constant, right? Now, how to find that constant, we're going to use this setup. Negative b over 2a. Those a's and b's are referring to, again, standard form. You have to be in standard form. So if you're in factored form, this won't work. If you're in the other square binomial form, this won't work. You have to be in standard form. It's very important. So identify A, B, and C, and then you are going to plug them in. Make sure you're using parentheses. Go ahead and add them in right now. All right, so that way you don't lose any negatives. All right, now how do you find it from a table? How do you find the symmetry from the table? What do you look for? How do you know it's the vertex, though? If you're looking at a table. Perfect. No other matching y value. There's no twin y value. Now, when we use that equation, or we find the symmetry in the table, we're actually looking at the what value of the vertex?
X.
The x value. So add this up here. You're not only finding the symmetry, you're actually finding the x value of the vertex too. Okay, that's going to help you in the next part down below, because now once you know the x value, how are you going to find the y value? Plug in that x value. Plug in the x, evaluate the x value to get the y value. All right, so when you found your x value for the symmetry equation, you're also going to use that to evaluate to find your y value, the vertex. Okay, so also in the table, you're going to find symmetry around y values around one center point. That is your vertex as well. All right, so the last thing you can take from our standard form is the y-intercept. The y-intercept, we could see the y-intercept very easily in standard form. There's a pun there. You could see the y-intercept in standard form because it's the c value. All right, let me move this up. Okay, you're looking at the constant term or the c value to see the y-intercept. All right, that is, let me move up a little bit again, as you can see it, there it is. I'm going to underline this c value up here to remind you that is our y-intercept. We're going to build it to be a coordinate, which we always know what's 0? X is always 0. The y value will be whatever the constant c is. Whatever the constant c is. Now, how are you going to find it in a table? How do you know you're looking at a y-intercept in a table? Yes? X is 0. Look for it when x is 0. So you're looking at a table. Look for when x is 0. That'll be your y-intercept. All right, let's go ahead and do the example below using this new information. All All right, so we're looking at this. It's not telling us to graph at all. So we don't have to graph this one, but we can find all these features without graphing. I could find the symmetry and the vertex together. I could also see the y-intercept in the equation. Since I'm already in standard form over here, okay, this is standard form, I could go ahead and identify what A, B, and C are, the numbers for A, B, and C. Let's make a list. A is what? 1. The coefficient in front of x squared is that invisible 1 right there. So A is 1. B is 2. B is 2. And C is -8. So after we list those, what can we actually identify? The y-intercepts, right? We have it in standard form. We know this is going to be our y-intercept value. So let's go ahead and start the list of these key features, starting with the y-intercept at 0, -8. At 0, -8. All right, we got that one taken care of. Now, we're left with symmetry and vertex. Always find symmetry first, then use it to find the rest of the vertex. So, let me get the right color. All right, so axis of symmetry, again, is the equation we're going to use, is x equals -b over 2a. I'm replacing the b from the coefficient in the equation and the a as well. That's why we list those a, b's, and c's first. All right, now let's go ahead and replace those using parentheses. I wish you could see me making that symbol. X equals negative empty parentheses over 2 times empty parentheses. Up top, our b value goes in there. B value is 2, goes inside there, and a is 1, goes inside there. Now distribute the negative.
You don't have to square it.
There is no square in there, no exponents, just negative b over 2 times a. So -2 on top over 2. What's -2 divided by 2? -1. Okay, there it is. Our axis of symmetry is always an x equals equation, a vertical line that goes through x equals -1. -1. Okay? Now, if you had a graph, you could think, hey, now I have a starting point for my table. I'm going to build my table around the vertex. All right, we don't have to graph it, but we do need to find the vertex. Make a different color. Vertex here is going to be red. All right, so how do I find the vertex if I know the symmetry? Plug in that x value. Okay, so I'm going to take the equation y equals x squared plus 2 times x minus 8. Again, that's the original equation up here. We're going to evaluate the symmetry x value of -1. We just got that -1 here. Put it inside for x. -1 squared plus 2 times -1. Double check your math on the calculator, or double check my math, I should say. -1 squared is 1 plus -2, so -2 minus 8. That's -1 minus 8. Did you guys get -9?
Yeah.
Very good. Y value of our vertex is -9. Okay. We could have actually wrote half the vertex earlier because we already knew what value of the vertex. The x is -1. That was going right there. We just evaluated -1 to get the -9 y value of the vertex. The -9 y value of the vertex. Got a little question down here. It says, does the quadratic have a max or min value? Does it have a max or min value? Which one does it have? A min. How do we know it has a minimum value? There's no negative in front of x squared. We see that a is +1. We know these positive ones are happy faces. Right? We know it's going to have a happy face, then it has to have a minimum value. That's where the vertex will be. A minimum value. at negative 1, 9. So a min value at, oops, not at, equal to negative 9. Practice young algebra Padawans on this example. Okay, you're making a list. I'll make it over here for you. You're probably going to find something first here. And if you think the y-intercept, is it negative 9? No, it is not negative 9. This is not in what form?
Standard.
Not in standard form. You're going to have to convert this to standard form in order to use what we just learned. So multiply this binomial out, simplify it to standard form. Okay, to multiply that out, remember we're going to expand out the two quantities of these binomials to multiply. This creates a perfect square trinomial of x squared plus 4x plus 4. We still have to subtract 9. So our simplified standard form is going to be x squared plus 4x minus 5. Now you can identify what A, B, and C are. Now you can see that it is not going to be negative 9 for the y-intercept. It's actually going to be what? Negative 5. Negative 5. For my y-intercepts. All right, go ahead and find the next things: the symmetry, vertex, and max min value. All right, now let's find the symmetry first. Our x value of the symmetry, our AOS, x equals negative b over 2 times a. Again, there is no a, b's, and c's in this funny looking form. You have to be in standard form down here to identify a, b, and c. So now we can do that. A is 1, B is 4. And now so we'll plug them in. Up top, we would have the B value 4, and on the bottom, A 1, it goes down there. Simplify this. We're going to have negative 4 over 2, which is negative 2. So there is not only my symmetry equation, but half of my vertex. The x half of the vertex. Now to find the other half, you got to plug in that x value into one of these forms. You could use the standard form, or you could use this form. If I have to plug in negative 2, which one looks easier to do? I disagree with standard form here. You got negatives getting squared and multiplying against positives. Look what happens if I put this negative 2 where x is up here. What happens inside here? Becomes 0. Let's go ahead and plug in that negative 2 to the easy one up here. Oops. So we got y equals x negative 2 plus 2 squared minus 9. What happens in the middle there? It becomes 0, and 0 squared is 0. So we get 0 minus 9. So that means what? That means my y value is negative 9 for the vertex. So negative 9 for the y value. All right, now how do we know it's a max or min? We have a vertex that's going to be below the x-axis. We know that because of the negative y value. We also know that's going to open up because the a value, there is no negative out front here. Whether you look at standard form or this weird form, a is positive. We know it's going to be an opening up parabola, so it has to open up towards the x-axis. That means this is going to be a minimum value down here. So another minimum value of negative 9. Okay, that's our min value. Always the y of the vertex. All right. When we were graphing the last notes, we had to choose our own x values. It was a shot in the dark. You're just like throwing darts, guessing what x values. Now we could have a way to find the middle. We're going to do that. We're going to find the vertex and build the table around the vertex. That'd be a more efficient way of building the problem. So what we want to do first is identify the, what do we always do first? What do you think we do first? Yes, identify the axis of symmetry. Okay, that will help you determine the what? The what of the vertex? The x value of the vertex. So first is identify the axis of symmetry. Use that equation. Okay, so add that in there. X equals negative b over 2a to get that x value. So once you have that, what do you do with to find the y value? You evaluate. So these are steps we've already done. Evaluate that x value to determine the y value of the vertex. Now you could write that vertex in coordinate form. Fill these notes out, right? Third is build a smart table. Not just a table of random x values, but a smart table. Well, why it's smart is because it's centered around our vertex that we just found out. We just calculated the vertex above, so build a table around that vertex. And when you do that, you're going to choose two consecutive, add this in, it did not get printed out, x values. Two consecutive x values that are blank to the vertex x value, and two more that are blank. What do you think? You're right. Before and after, or mathematically less than, so two values that are less than the vertex x value, and then two more that are greater than. Okay, you're looking for values on both sides of the vertex. X values on both sides. All right, let's do these first steps with the example down below. Okay, first of all, we don't have the standard form, so we have to convert this to standard form. Let me do that for you really quick. If you multiply this out, you're going to get negative x squared minus 2x plus 3. Now that we have standard form, let's identify a, b, and c. A is negative 1 right there. There's my b value, negative 2. And my c value, we're going to use that a little bit later. C is 3. C is 3. All right. Now let's find our symmetry using our equation. So symmetry here, AOS, x equals negative b over 2a. Plug in the values. B is negative 2, a is negative 1. If we simplify that, we would have a negative times a negative on top to get positive 2 over negative 2. What's that equal? Negative 1. Negative 1. So our symmetry equation is x equals negative 1. That tells us what also? The x value of the vertex. All right, now that we have our symmetry equation, x is negative 1, we're going to now need to find the vertex y value. That's our x value of the vertex. Now we got to find the y value. So remember, we're going to plug that x into the function. You can use either form for this. Let's use the standard form over here. So y equals negative parentheses x squared minus 2 times x plus 3. And we're plugging in negative 1 for the x value. So when you evaluate that, we're going to get negative 1 squared is 1, but then negative 1 from the outside negative. This becomes plus 2 and plus 3. All right, so negative 1 plus 2 plus 3 is going to equal 4. So my y value of the vertex is 4. So let's go ahead and identify that. Vertex was -1 for the x, +4 for the y value. Let's go ahead and put that right in the middle of our table. Right there. So that -1 and the y value, 4. All right, so we just completed actually the first 2 steps. That was step 1, let's find the symmetry and x value of the vertex. Step 2 was to find the y value of the vertex and put it in our table. And now we're doing part 3. We're building the table around the vertex. So 2 values less than -1, -2, and -3. And remember, make those consecutive values in order. And just the other way, I'm going to have 0 and 1. I think just adding 1 in both directions. All right, we're going to evaluate those values. That's the next part. That's our step 4. It's complete the table. So let's go ahead and do that. All right, using a calculator, we evaluate these x values. The first one, -3, gives an output of 0. Ooh, that should be something special about our graph. Plugging -2, output of 3. We already have the vertex value there. And then on the other side of the vertex, 0 puts an output of 3. And then we get 1 in, 0 comes out. Another interesting 0 here. We have a 0 here and here. Now, when we build the table, we should see symmetry right in the middle because we chose the vertex. All right, now that we've built our table around the vertex, chose these x values on both sides, evaluated these x values in step 4, complete the table. Now, our last thing to do is to plot the points and graph this parabola down here.